10th Standard Geometry, Chapter 3, Circles, Module 8. In this module, we'll study about Problem Set 3, Part 1. Let us start with the first question in the Problem Set 3, that is choosing the correct alternative and giving the right answer. So the first question was, two circles of radius 5.5 centimeters and 3.3 centimeters respectively touch each other. What is the distance between their centers? The following are the options: 4.4, 8.8, 2.2, and last one is 8.8 or 2.2 centimeters. Now let us start with the solution. Now, if you read the question carefully, in the question it is not mentioned whether the two circles are touching internally or externally. So we find it out both. So if the circles are touching internally, then the distance between their center will be sum of their radius. So that will be 5.5 or 3.3. And if they are touching externally, then the distance between their centers will be the difference between their radius. So that will be 5.5 minus 3.3. So 5.5 plus 3.3 is 8.8 and 5.5 minus 3.3 will be 2.2. So the correct answer is D, 8.8 or 2.2 centimeters. Second question, two circles intersect each other such that each circle passes through the center of the other. If the distance between their centers is 12, what is the radius of each circle? So if you look at the diagram, two circles intersect each other. Each circle passes through the center of the other. Distance between their centers, that is distance between P and Q, is 12. We have to find out the radius. So if you look at the diagram carefully, PQ will be the radius of the first circle. Similarly, PQ will be the radius of the second circle. So from the following options, option B will be the correct one. Third, it said a circle touches all sides of a parallelogram. So the parallelogram must be dash. Options are, should that parallelogram be a rectangle? Should it be a rhombus? Should it be a square? Or should it be a trapezium? So if you see the following figure, the circle touches all the sides of the parallelogram ABCD. So what this parallelogram ABCD should be? Which of the following? Now the answer to this is ABCD should be a rhombus, because it cannot be a square nor a rectangle, because angles are not mentioned to be as 90 degree. So if the angles are 90 degree, then we can say it could be a rectangle or it could be a square, but neither of the thing is given in the question. So this parallelogram should be a rhombus. So answer B is the correct answer. The fourth one, length of a tangent segment drawn from a point which is at a distance 12.5 centimeters from the center of a circle is 12 centimeters. We have to find the diameter of the circle. So if you see the diagram, the length of the tangent segment drawn from a point is a distance of 12.5 centimeters. So this is 12.5 centimeters. From the center of a circle is 12. So this is 12. We have to find the diameter of the circle. Is it 25, 24, 7 or 14? Let's start with the solution. Now if you see in triangle OAB, B is a 90 degree because radius is perpendicular to tangent by tangent theorem. So we'll use Pythagoras theorem that says OA square will be equal to OB square plus AB square. OA is 12.5, which is given in the question. OB, that is radius of the circle, which we have to find out, and eventually using the radius we'll find out the diameter. AB is 12 centimeters is also given in the question. So we'll take this 12 square on the other side. So we get 12.5 square minus 12. So 12.5 square is 156.25 and square of 12 is 144. Once we subtract it, we get it as 12.5. We take this square on the other side and hence it will become the square root of 12.25, which is 3.5 centimeters. So the radius of the circle, if you see OB is the radius is 3.5 centimeters. We know that diameter of a circle will be twice the radius. So we multiply 3.5 by 2, which is 7 centimeters. Hence diameter of the circle is 7 centimeters. So option C will be the correct answer, that is 7 centimeters. Fifth one. If two circles are touching externally, how many common tangents of them can be drawn? Can you draw one tangent, two tangent, three tangent, or four tangent? So if you look at this diagram, two circles are touching externally. So if you see, these are all the possible tangents that you can draw, which will be common to both of the circle. So I can draw one tangent at that passing through that point which is common to both the circles. So line L is a tangent common to both the circles. Similarly, line M is a tangent common to both the circle, but they are at different points. While line N is also a tangent which is common to both the circles, but at different points. So if you count, we can draw 1 line L, 2 line M, and 3 line N. So we can draw 3 tangents that is common to two circles touching externally. So line L, M, and N are the tangents. So C, 3 tangents is the correct answer. Sixth, angle ACB is inscribed in the arc ACB of a circle with center O. If angle ACB is 65 degree, find measure arc ACB. So if you see, ACB is inscribed in the arc ACB with the center O. Angle ACB, that is this angle, is given to you 65 degree. We have to find a measure of the arc ACB. So the following are the options: 65 degree, 130 degree, 295 degree, or 230 degree. Let us start with the solution. So ACB is the inscribed angle. And we know by inscribed angle theorem, the inscribed angle will be half of the corresponding intercepted arc. So ACB, inscribed angle, is intercepting the arc AB. So angle ACB will be half of the measure arc AB. If we take the 2 on the other side, we get measure arc AB is equal to 2 into measure angle ACB. Now measure angle ACB is given to be 65 degree. So we'll substitute 65, and 2 into 65 is 130 degree. So measure of arc AB is 130 degree. But in the question they have asked to find out measure of arc ACB. We have found out AB, but we have to find out measure of arc ACB. Now if you note one thing, AP, arc AB is a minor arc and ACB is the major arc. So we'll use our formula, measure arc ACB, that is the major arc, will be equal to 360 degree minus measure of the minor arc, that is AB. Now measure of the minor arc we have found out, that is 130 degrees, so we'll just substitute it. So this will be 360 minus 130. So 360 minus 130 is 230 degree. Therefore, measure arc ACB is 230 degree. Hence, in this, option D will be the correct option. The seventh question. Chord AB and CD of a circle intersect inside the circle at point E. If AE is 5.6, EB is 10, CE is 8, we have to find ED. If you look at the diagram, AE is 5.6, EB is 10, CE is 8. We have to find ED. The options are 7, 8, 11.2 and 9. Let us start with the solution. Chords AB and CD, they intersect internally at point E. So we'll use the theorem of internal division of chords. That will be AE into EB equal to CE into ED. AE is 5.6 centimeters, so we'll substitute it. EB is 10, we'll substitute it. And similarly, CE is 8, we'll substitute it. We have to find ED, so ED as it is. So if we simplify this, 5.6 into 10 divided by 8, the final answer that we will get is 7 units. So ED is 7. Hence the correct option is A, 7. The eighth question. In a cyclic quadrilateral ABCD, twice the measure of angle A is thrice the measure of angle C. We have to find the measure of angle C. So the following are the options: 36 degrees, B 72 degree, C 90 degree, and D 108 degree. Let us start with the solution. So it is said in a cyclic quadrilateral ABCD, twice the measure of angle A is thrice the measure of angle C. So first of all, we'll start with the quadrilateral ABCD. ABCD is a cyclic quadrilateral, and we know that by cyclic quadrilateral theorem, opposite angles of a cyclic quadrilateral are supplementary. So angle A and angle C will be the opposite angles, and angle A plus angle C will give you 180 degree. That is by theorem of cyclic quadrilateral. Also, if we multiply 2 throughout, 2 into A plus 2 into angle C is equal to 2 into 180 degree. So we get, and now also in the question it is said, twice the measure of angle A is thrice the measure of angle C. That means 2 times angle A will be equal to 3 times angle C. So 2 into angle A is equal to 3 into angle C. So here in place of angle A, 2 into angle A, we'll write it as 3 multiplied by angle C. So now 3 angle C plus 2 angle C equal to 360 degree. Now we're just adding the left hand side, 3 angle C plus 2 angle C, we get 5 times angle C equal to 360 degree. So we take the 5 on the other side, it will get divided by 360. So we get 360 divided by 5, which is 72 degree. Therefore, angle C is equal to 72 degree. So option B is the correct option, 72 degree. The ninth question. Point A, B, C are on a circle such that major arc AB is equal to major arc BC is equal to 120 degree. No point except point B is common to the arc, which is a type of triangle ABC. So we have to find out what is triangle ABC. Is it an equilateral triangle? Is it a scalene triangle? Is it a right angle triangle? Or is it an isosceles triangle? So if you look at the diagram, A, B, C are on the circle, and arc AB and arc BC are equal, and both of them are 120 degree. And no points except point B is common to the arc. So these two arcs have only one point, that is point B common. Now we have to find out what type of triangle is ABC. So let us start with the solution. Now, if you look at the arc AB plus arc BC plus arc AC, they form the entire circle, and hence arc AB plus arc BC plus arc AC will be 360 degree. That is measure of circle, that is 360 degree. Now measure arc AB and measure arc BC is given to you 120 degree, so we'll substitute it. Measure arc AC will keep it as it is because we have to find it out, equal to 360 degree. So if we subtract it, 120 plus 120, that is 240, and we take 240 on the other side, we'll get 360 minus 240, which is 120 degree. So arc AC is also 120 degree. So arc AB 120, arc BC 120, and arc AC as well 120. Now, since the arcs are congruent, their corresponding chords will also be congruent, and this is by corresponding chords of congruent arcs of a circle are congruent by the theorem that we studied in our previous modules. So if you see, corresponding to arc AB is a chord AB, corresponding to arc BC is a chord BC, and corresponding to arc AC is a chord AC. So if the arcs are congruent, their corresponding chords are also congruent. Now these chords are nothing but the side of the triangle. So each of the sides of the triangle are equal. Now when each of the sides of a triangle are equal, such type of triangles will be called as equilateral triangle. Therefore ABC is an equilateral triangle. Hence option A is the correct option. The 10th sum. Segment XZ is a diameter of a circle. Point Y lies in its interior. How many of the following statements are true? So we have 4 statements here. The first statement is, it is not possible that angle XYZ is an acute angle. Second statement is, angle XYZ can't be a right angle. Third statement is, angle XYZ is an obtuse angle. And the fourth statement is, can't make a definite statement for measure of angle XYZ. So you look in the figure, XZ is the diameter of the circle. Point Y lies in its interior. Let us start with the solution. XZ is the diameter of the circle. So angle XWZ will be a right angle triangle, because we know that angle inscribed in a semicircle is a 90 degree angle or a right angle. So if XWZ is a right angle, Y lies in the interior of triangle XWZ. So angle XYZ will be greater than 90 degree because it lies in the interior. Therefore, we can say that angle XYZ is an obtuse angle. So from here, option A says only 1 is correct. Option B says only 2 is correct. Option 3 says only 3 is correct. And option D says all is correct. But from our solution, we can infer that angle XYZ is an obtuse angle. That is the third statement. So we can say that option C, that is only the third statement, is correct. As XYZ is greater than 90 degree, it will be an obtuse angle. So if you see in the figure, the angle that is inscribed in the semicircle is 90 degree angle, and Y, since it is in the interior below in the interior of the circle of the triangle XYZ, it has to be greater than 90 degree, and we know greater than 90 degree is an obtuse angle. Hence option C is only 3, that is only the third statement, that is angle XYZ is an obtuse angle, is a correct option.